Hi, Ken from MakeTech here. In this video we're going to do an update since the last video about a week ago. I've been quite busy. It's mainly going to be time-lapse videos of some Arduino and Arduino shields that I've made for those, some associated electronics with that, cable management and some 3D printing. Alright, let's get into it. Okay, so we're starting off here with a little terminal block enclosure. This is taking signals from the spindle and sending it down to the breakout boards. It's going to be connected to the Ethernet smooth stepper. So it's pretty quick and simple little build. For this one I've used these nice, I think they're nickel or chrome plated glands they're called, and the purpose of those is to make a nice watertight seal on the enclosure around the cable, because this will be having cutting fluid spraying everywhere, and I don't want cutting fluid up inside the terminals, obviously. So here I've got a bit of heat shrink on there, and this is a, they call it expanding sheath, I think it's called. And so the way that works is it's like a plastic braid that when you push it together lengthways, it opens up like a snake's mouth, and then you can feed your cables through there. And then when you stretch it back out again, you get a really nice professional finish on your cables. And then if you need to, you can heat shrink over the ends, and that seals off the ends because you have the little loose braids. So here I've got the 3D printed bracket that I designed in Fusion 360 on these pneumatics valves. So I needed some way to mount the 5 valves onto the backing plate there. So that was just a pretty simple little design. It's nothing too fancy. Now, so basically just working out the spacing for the valves. So I didn't want them all to be evenly spaced. I needed some space for that manifold. It's like a 1 in, a 10mm in, 10mm out manifold with 10 6mm outputs for the pneumatics. And yeah, you can see there on the desk I've got a little pressure sensor as well. I'm not sure if that's going to go in this enclosure, or I might have that on the air tank that's going to go under the machine. So yeah, that's a really nice enclosure. That's from Element 14 as well. I believe it might be the same manufacturer as the other large enclosure that you can see next to it there. Okay, so here I'm just feeding through the pneumatic lines. And then I've sort of cut them all to the same length and hooked them into the valves. And here's a pump shroud. I designed this one in Fusion 360 as well, and printed that out on the Prusa i3 Mark III's. And you can see the workflow. Pretty simple design. Turned out quite nicely. This is eSun ABS. And then I've just got a little raft edge there, just peel that off, and then I'll use a file to clean it up a bit more. It's a bit fiddly, but it's nice. It's a nice way to help it give bed adhesion, because on large prints they can peel up off the bed, especially with ABS. ABS shrinks. And in this 3D printer enclosure, I've actually put a heating system in there. I can look at that in another video. So you see it slides on nicely. So the coolant can go up through that sort of cable management Corrie, they call it. Corrugated conduit, flexible conduit. And now, unfortunately, as I'm manipulating this into place, this old pump has a worn out connection on the top. I believe the plastic was a bit weathered and it snapped as I was trying to get things into place, so that was quite frustrating. But it's not the end of the world, because that pump had already basically served its purpose from when I had it in an earlier project years ago, and it had a leak, so I needed to replace it anyway. And now this has just pushed me to the point where I have to replace that pump sooner rather than later, so that's fine. And yeah, the Tunes aquarium pump that I originally had planned for this just didn't quite have enough head height to prime the system easily, so I decided not to use that in the end. But alright, now we're on to the Arduino stuff that I was talking about. So the Arduinos that I've got here is a Mega, that's the Arduino branded Mega, and some other third-party brand Arduino Nano. So for this one, this Mega has basically hardly been used. It was just in like a DIY PLC project. I was demonstrating recording data to the EPROM for some engineers I was working with, and so I'm going to salvage this fine unit out of there, and all I'm doing is making a shield, they call it. It's like a PCB that just drops straight into the terminals on there, and all it's going to have on it is screw terminals for cables, so that I can mount this in the electrical enclosure and then have a nice professional way of connecting everything up. So this will give me a way to connect to the breakout boards. The interesting one about this is I had to solder the pins coming off the back of the board, you would call it, and that's a little bit unconventional, but for this one I've got components on both sides of the board, and so yeah, to solve that problem, that's the way I did that, and it turned out really nicely. These blue screw terminals have a pin spacing that's every other pin compared to the Arduino pin spacing. So all I've done there is had one row for odds and one row for evens, so each side of the Arduino board actually has 2 rows of terminals. Now I'm just soldering up the pins onto the Arduino Nano. And then I've got like a pin socket I'm soldering into the board for that one, and that one also has the blue terminals on the odds and evens spacing. And here it's done pretty quickly there, but you can see I'm using the drill to actually drill through the copper tracks so that they're insulated from one side to the other. It's a trick that I've learnt a few years ago. It works quite well. Obviously you don't want to drill right through the board or the board's going to break in half, but you just need to take off that first little layer with the copper. And here I'm just running the 9 wire. Okay, well, yeah, you can see I broke the pump. Okay, so alright, that's it. It's not the most amazing video this week, but yeah, I've been busy and I'm just going to leave it at that, so stay tuned for more, and thanks for your support everyone. Bye.